let me just repeat what I just told the class. We are going to continue reviewing for the test that is on Wednesday, which is our next class period. And this is an old exam that I gave last semester, and this is the second part. We had started on the first part last class period. Okay, so we have the following. This is a preference schedule, and we want to answer the following questions. I'm looking for my calculator. Okay, so looking at that, how would you guys tell how many people or how many people voted?
You would add the number of voters.
And how do you know where the number, oh, okay, because it says number of voters right there. Yeah, so add all the number of voters, so 15 plus 11. And so when you're showing your work, I mean, you will get some partial credit if you show that that's what you're doing, right? So 15 plus 11, and I'm not sure if this will work. 15 plus 11 plus 9 plus 6 plus 2. So this is 26 plus 9 is 35, 35 plus 6 is 41, 41 plus 2 is 43. And so if the winner of the election is determined by the border count or border point, calculate the border points for each candidate and determine the winner. So there's 4 candidates here. But instead of giving 4 points for first place, 3 points for second place, 2 and 1, this is telling us that we want to do it a little differently. We want to give 3 points for first choice. And then we want to give 2 points for second choice. And 1 point for third. And that fourth place winner gets 0 points. Okay, so we got to figure out everybody's board account. And so let's look at player A first. And so looking at player A. So looking at the first column, they were chosen in first place by 15 players here. And so that's 3 points, all times the 15. And in the second column, there's 11 people, and they chose A as last choice. And last choice was 0 points. So 0 all times, well, it really doesn't matter, but 11. Oops, A is all last choice here. So really 0 times 9. Plus 0 times 6 plus 0 times 2. So really, they only have 3 times 15 or 45 points. And so let's look at player B. Player B So player B, let's just go for first choice. We can do this a little differently if we want. So first choice, they get 3 points. And looking at this, there's only one place that they have first choice, and that was with 6 people that voted for them, him or her. Player B also was ranked second choice, which is worth 2 points. Well, they're second choice in 2 separate columns for 15 people plus 11 people, which is 26. And then third choice, there's 2 places where he was ranked third choice, and that's only worth 1 point. And that 1 point was for 9 people plus 2 people, which is 11. So B is equal to 3 times 6 is 18, plus 2 times this 26 is 52, plus 1 times this 11 is 11. 18 plus 52, 70. That's 70 plus 11 is 81. So we just have C and D left. So if we go through here and find C, C was ranked first place 2 different places, and that's 11 plus 2, which is 13 players. So 13 players times the 3 points for first place. So C was only ranked once, or in this row once, for second place, and that was 9 players. And that was worth 2 points. And then C was ranked third by 15 players here and 6 players here. So that is 21 players. And first place, that is worth 1 point. So C is worth 3 times 13 is 39, plus 2 times 9 is 18, plus 21. So 21 plus 39, that's 40, 60. 60 plus 18, so that should be 78. And then let's do D. So D, for first place, he was in here 9 times. So 9 times 3. Plus D, second choice, 6 plus 2, so that's 8. 8 times 2 points. D was in third place 11 times, so plus 11 times 1 point. And he was in last place 15 times, and that's 15 times 0. So 9 times 3 is 27, plus 8 times 2 is 16, plus 11 times 1 is 11. 53. So 27 plus 16 is 43. 43 plus 11 is 54. So the winner of this election goes to B. So questions on that? Okay, so looking at the same preference schedule, which is listed again, for the election for problem 1, use the method of pairwise comparison to calculate the answers. So this is where you have to go through and compare each one. So looking at each column, you're looking, is A ahead of B or B ahead of A? And so let's just circle whoever is ahead in each column for A and B. So first column, A is ahead, Second column, B is ahead, B, B, and B. So A, right, is 15. I felt like we did this problem already. And B is 11 plus 9 is 20 plus 6 is 26 plus 2 is 28. So B is the winner there. So we got to do the same thing with A and C. The thing is, A is always the winner for the first one, 15. They're always going to have 15. And the other winner, the other person that we're ranking them against is always going to be ahead of them for the other places, right? And so we can put 28 in here, 28 in here. So C wins, D wins. Ranking B now with C. So B wins here, C wins here, B wins here. Oh, C wins there. B and C. So if I calculate how many times B is in there, that's 15, right? Plus 6. So that's 21 times. And then the remaining, so 11 plus 9 is 20 plus 2 is 22. So C wins there. So looking at B versus D, B is the winner here, B is the winner here, D is the winner, B is the winner, D is the winner. So if I add all the B's, that's 15 plus 11 is 26, and 26 plus 6 is 32. And D, that gives me 9 plus 2, which is 11. So B's the winner. Last one, C versus D. C is the winner in the first column, C is the winner in the second column, D is the winner in the third column, D is the winner in the fourth column, and C is the winner in the fifth column. So calculating C, 15 plus 11 is 26, 26 plus 2 is 28. And the remaining is 9 plus 6, which is 15. When you go through this, when you sum both of these, they all should be calculating up to the total number of votes of 43. Okay, so pairwise comparison, A has won how many times? Nada. B has won once, twice. C has won once, twice, 3 times. And D has won once. Okay. And so our winner here is C, which is 3. Okay, so different winner, different outcome, or different outcomes based off of how we did it. Okay, so a good review. Sorry, that was one that we did last week. Did I start on the second test last week? Okay. That was, see if I can find this other one. It's all jumbling. Okay, come on. Okay, so use the following weighted voting system. So how many players are in the weighted system? So again, this is just written up a little differently. And so our weighted voting system, we can tell how many players, oops, actually, how many players are we counting up this row? How are we going to find out how many players? What are these numbers representing?
Those numbers are the weights. So the number of players should be the number of numbers that we have there, which is 2, 4, 6, it's 9 players.
Okay. So, oops, darn it. So don't, but you weren't counting that first number, right? So we got player 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. And then the quota is, looking at that,
20.
20. And in this weighted voting system, what is the minimum percentage of votes needed to pass a motion? Well, it depends on if we're doing it as we want half, then we would have to look at this. I'm sorry. In this weighted voting system, what is the minimum percentage?
I don't know.
So
I mean-
I was thinking of the question wrong, but go ahead, Tyson. What were you going to say?
Oh, I was just gonna say there's 38 total votes and you need 20 to pass it. I think I counted that right, but I also might have messed up. So.
Yeah, so we need to look at the weights and calculate all the weights for every single player. And so if we calculated the weight, so sum that up. I'm just going to put this on and see if that glove will stop the page from jumping. So 7 plus 5 plus 4 plus 4, that's 8, plus 2 plus 2 plus 2, that's 6, plus 1 plus 1, that's another 2. That gives us, so summing all this up, I got 28. Is that what you guys got? So there's 28 votes, and we want to know
33 total. Sorry, 33.
33? 7, 5, 8, 6, 2. Mine?
My bad. Yeah, it's 28. Sorry.
Okay. I just want to make sure. So the quota was 20, right? And so this is 20 out of 28 votes. And so we could figure out what that percent is. So 20 divided by 28. So that gives us approximately, well, that's 71.714. So basically we got to round up, because it doesn't make sense to have a partial vote. So they need about 72%. The minimum percentage is 72% of the votes to pass. Okay, so consider the generic weighting system, Q, W sub 1, W2, W sub 3, W sub 4, W sub 5. Suppose the winning conditions are the following. So player 1, 2, and 3, coalitions. A coalition, player 1, 2, 3, and 4, player 1, 2, 3, 5, a player 1, 2, 3, 4, 5. Find the bonds off power distribution for each player. Okay, so bonds off power. Remember, bonds off power, a player was, it was pivotal, or was it, is that what we called it? No, pivotal was for the Shapley Shubik. Bonds off power, you had critical players. You were a critical player if you were removed from the coalition, it would no longer be a winning coalition. And we had to look at how many times that happened. And so let's look at all of these. I'm just going to rewrite them. So these are all of our winning coalitions. And so we have player 1, player 2, and player 3. We also have player 1, player 2, player 3, and player 5. We have, oops, sorry, that was 4 and then 5. Doesn't really matter. Player 4, player 1, player 2, player 3, and player 5. And then the coalition that has everybody. Player 1, player 2, player 3, player 4, and player 5. So we want to know who is critical in this first winning coalition. And so if we removed player 1, we took out player 1 from that coalition, would player 2 and player 3 be a winning coalition? Well, if it was, it would have been listed in this list, right? So player 1 is critical here. And so I'm going to underline them. Same sort of idea. If I remove player 2 from this coalition, player 1 and player 3 would be remaining. And that is not a winning coalition because it's not listed here. And so player 2 also has to be a critical player. So same reasoning with player 3. If I had seen player 1, player 2 up here, they wouldn't be critical, but I don't see it. So all of them are critical players there. Same sort of idea for the second one. If I remove player 1, would this still be a winning coalition? Well, if player 2, player 3, player 4 could win that coalition, it would have been one of these and it would have listed it. So same reasoning as above. Player 1 in this case would have to be a critical player. Player 2 will be critical, player 3 would be critical. But if I take out player 4, that's okay. That's a winning coalition above. So player 4 in this case is not critical. So same reasoning as this third one with player 1, player 2, player 3, and player 5. Player 1 is a critical because these 3 could not win. Player 2 is critical, player 3 is critical, but player 5 is not. Player 1, player 2, player 3. So if we look at this, player 1, they had 1, 2, 3. Oops, sorry. No, they did not. Let me see. They had 4 times that they were a critical player. There were 4 times player 2 was critical. And there was 4 times player 3 was critical. Player 4 was never critical, and player 5 was never critical. The total number of critical players in this whole winning coalition group was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the the bonds off power is going to be 4/12, which reduces to 1/3 for player 1. The bonds off power index for player 2 is 4/12, which is also 1/3. Bonds off power for player 3 is also 1/3. Player 4 has 0 and player 5 has 0. All right. You guys good? Why does that keep moving? Okay, so the next problem, consider the weighted voting system where we have the quota is 8, player 1 has a weight of 6, player 2 has a weight of 3 votes, and player 2 is 3, player 3 is 2. So how many different coalitions are there? So how do we find the number of different coalitions? So wasn't that was looking at the number of players? So there's 3 players. So how did we do that?
Is the number of players factorial?
So if we look at 3 factorial, and how did we do factorial?
3 times 2 times 1?
So 3 times 2 times 1, so that gives us 6 times 1 is 6. Everybody agree? Okay, so this is where we have different coalitions, and the different coalitions order matters. And so first thing that we could have, notice that none of these would be a winning coalition by themselves. And so all the ones where there are coalitions where it's just them that came in to vote, it wouldn't win. So now let's look at if we had player 1 and player 2. And they broke this down. Sorry, it's been a little while. Probably the same with you. A couple weeks, right? That was where, sorry, that's 2, 3. I'm thinking I'm doing the wrong notation. Yeah, this is where it kind of looked like a greater than and less than sign. So here we have player 1 and player 2. If it was player 1 and then player 2, well, if player 1 was by themselves, they did not win. Player 2 coming in makes this a winning vote. And player 3. And then we have player 1, player 3, and player 2. So player 3, 6 plus 2, that would be 8. That is a winning coalition. And so player 3 would be the pivotal player there. And that's the only case with player 1 first. Then we looked at player 2 being first, then player 1 coming in, and then player 3. Well, player 2 is 3 points, then plus the 6, that is 9 points. So player 1 would be the pivotal player there. Could that also be where it's player 2, player 3, and then player 1? Well, player 2 is 3 points plus player 3 is, so 3 plus 2, that's 5 points. That's not going to win the election. And so we need player 1, they're pivotal. And then player 3, that could have been the first person. Player 3 and then player 1. Player 3 is 2 plus player 1, which is 6. That's 8. That's all they need. And player 1 would be critical. Then we have player 3, player 2, player 1. 3 and 2 together, we saw before, did not work. And so player 1 is critical. Sorry, I thought we were doing the Shapely Shubik. We're gonna take that down. Come on. So let's just finish that. So find the Shapely Shubik power distribution. So for player 1, they're underlined how many times? So 1, 2, 3, 4 times. Player 2, they're underlined one time. Player 3, they are underlined. Player 3, where are we at? Player 3 is never they're underlined once. And that's all the players we have. Okay, so the Shapely Shubik power for 1. Wrong symbol. Is 4/6 or 2/3. The Shapely Shubik power for player 2 is 1/6. And same thing with player 3, it's 1/6. So this is where it said sequential. Okay, so when they were saying how many different coalitions, they were talking about up here the bonds-off power. And so you got to look at that. And so this was, when we did this, this was 2 raised to the 3rd power minus 1. So 2 cubed is 8, 8 minus 1 is 7. So you had to look at all the subsets. So this is where you could have had player 1 is one set, player 2 is one set, player 3 is one set, then player 1, player 2, player 1, player 3, player 2, player 3, and player 1, 2, 3. And we don't consider the empty set as one of them. And then if we're calculating the bonds off power, this is where we went in to see if someone was a critical player or not. Well, player one, this is not a winning coalition. We don't even have to look at this. All these single ones are not winning coalitions. None one can go in there and win that motion by just being by themselves. Player one and player two, well, if I removed either one of those, that would just leave one person left and they're both critical players. 1 and 3 we saw could pass it, and so those are both critical. Player 2 and player 3, that is not a winning coalition. We don't even look at that. And then if they're all together, well, player 1, if he was removed or she was removed, the 6 votes, that would make this not winning. If player 2 was removed, that would give 6 and 2 here, and that's winning. So player 2 is not critical. And player 3, if we remove them, they would still win the coalition, so they're not critical. And so to calculate the bonds off power, the total number of critical players in here, there's 1, 2, 3, 4, 5. And so the bonds off power for 1, that should be a B, not a beta, is 1, 2, 3. Power for player 2 is just once, and the power for player 3 is just once. And so bonds off power for player 1 is the bonds off power all over the total. So 3/5. Bonds off power for player 2 is 1/5. And for player 3 is also 1/5. Okay, so last problem. A law firm is run by 4 partners, A, B, C, and D. Each partner has 1 vote, and decisions are made by majority rules. But in the case of a 2-2 tie, the coalition with player B, the senior partner, wins. Okay, so they need majority to win. So majority rule, well, there's 4 partners, right? And so majority to win would have to be, they need 3 votes. Okay, so list all the winning coalitions in this voting system and the critical players. Okay, so all the winning coalitions. If we just had player A, they would not win. If we have A and B, that would be a tie with C and D. The A and B, if that is a tie, we said that a tying coalition would win with B. So an A and B is a winning coalition. Order doesn't matter here. It would also be winning if A, B, and C were there. It would be winning if A, B, C, and D were there. And let's see what else. Let's look at A with just 3 people. So A, we have A, B, C here. A, B, D would win. Okay, so B, 3 people. 3 people will win. So B, C, D would be a winner. I think we got all the cases with 3 people. A, B, C, A, B, D, B, C, D. And then we got the one with 4 people. Is there, so other winning 2 coalitions, anything, 2 players with B would win. So B and A won, B and C would win, and B and D would win. So list all the winning coalitions in the system and the critical players of each. Okay, well, if we removed A from A and B, that would lose because it's not half, it's not majority. Same thing with B. So if we remove A, they would still win because B is with C. B can be, there could be 2 players with B and that would still win. So A is not critical. A and C cannot win by themselves. They need B in here. So B is a critical player and C is not. So A is not a critical player if everybody's there. B is not a critical player because A, C, and D could win by themselves. C and D are not critical players. So no one's a critical player when all 4 vote, because removing one of them could still make it a winning coalition. So if we removed A from this ABD, it's not going to work. I mean, it will still win, so A is not critical. If we remove B, though, A and D cannot win in a tie without B. Same sort of idea down here. So B is the critical player when there's 3 players. B and C are both critical players here, and B and D are both critical players. So determine the bonds off power for distribution for the law firm. Well, B sub 1, how many times? We have 1, 2, 3, 4, 5, 6 times. He's a critical player, and the total number of critical players are 1, 2, 3, 4, 5, 6, 7, 8, 9. So his bonds off power index is 6/9 or 2/3. Sorry, that was for player, that was for B. I said player 1. I don't know if we want to call him player 1 or not. So I'm going to get rid of that subscript. So for A, their bonds off power for A index, they've only 1 time. So this would be 1/9. So for C, same idea. There's only 1 time they were a critical player. Their bonds off power index is 1/9. And D, there was only 1 time they were a critical player. So their bonds off power is also 1/9. Okay, so class against instructor. We have Jeopardy here. We have definitions. We have bonds off. We have dictator veto power dummies. And we have the shapely Shubik power. And no points for the end. So, Pablo, you want to start us out and give us a category and how many points you guys are going to do?
Definitions 400.
Okay, let's see what you guys have. Or simply majority is exactly half, and anonymity is everybody has to agree.
Is that a false or true question? Because that's not true.
Simply majority is exactly half, and we didn't talk about anonymity, is everybody has to agree. I think that I don't even know this one.
Well, I'm just gonna say false.
So what is simply majority and anatomy? So
Also, it showed the answer.
I don't know what that was all about. Let's just, okay, now we know how it plays. So they have like a huge group or a pool of questions in here. So I, of course, just came in and grabbed one that looked good. I didn't see that one. But anyway, so Paul, try one more time.
Let's do definitions for 500.
Okay. Let's see. A mathematical method for measuring the power of the player.
Ooh.
It could be the gunshot power.
Okay. You guys agree?
Yeah.
Okay. So mathematical method for measuring the power of the player. So you guys got it. Bonds off power. You will be team one. 500 points. Okay, I'm just going to start with the ones I can see. So Catherine, what would you like?
Can I go bonds off for 100?
Okay, so we got the bonds off power. So solve 4, 3, well, we got the quota of 4. We have player 1 has a weight of 3, player 2 has a weight of 2, and player 1 has a weight of 1. And so I'm just going to pause the recording while we work on that. Okay, so students have chimed in after working for a little bit that they got player 1 has a bonds off power of 3/5, player 2 has a bonds off power of 1/5, and player 3 is 1/5. And I think you guys are correct, but let's see what they say. Okay, so they just went into percentage, which is okay. 3/5, if you do 5 divided into 3, well, that's 0.6 or 60%. For player 2 is 20%, player 3 is 20%. Okay, so you guys got 100 points. So I feel bad because I'm actually picking on the ones that have their cameras on. But since I already started, Cheyenne, you want to tell us what category, because I don't want to leave you out just in case you wanted to pick.
Can we do definitions for 100, please?
Yep, so definitions for 100. So refers to the voters. That's another name for that.
Players?
Everybody agree or anyone not agree? Okay. What are players? Okay, what about you, Dolores? You around? I know some of you have little kids or you have kids that sometimes you're walking away. Anyone else want to chime in? Definitions, okay, yeah, definitions for 200. player's weight is bigger than or equal to the quota. What is it called if a player's weight is bigger than or equal to the quota? So I see the mouth of what it was. So so what I think I read correctly was dictator. Okay, everybody agree? Okay, let's see. What is a dictator?
I'll do definitions for 300.
Okay. So the minimum number of votes needed to pass a motion.
What is quota?
Oh, God.
Everybody agree?
Yeah.
Okay. You guys got it. Okay. Next.
Let's go dictator veto power dummies. 100. Just, yeah.
Okay. Is there a dictator, veto power, or dummies in here? So 11, 5, 2, and 1 are the weights, and 15 is the quota.
That would be no dictator 11 with veto power. Right?
What about a dummy?
I'm going to phone a friend.
You gonna phone a friend? So one, it sounds like someone says one is a dummy.
So 2 and 1 would be dummies.
The people that have votes of 2 and 1 would be a dummy.
Because they can, yeah, okay.
So they can never help, right?
Influence the vote at all?
And these people can never win without, right? First player. What about this second player? Well, they can also.
Is needed.
They're needed, right? So if they're needed, does this person have veto power?
Yeah, 11 and 5 have veto power.
So there's no dictator. The veto powers are 11 and 5, and the dummies are 2 and 1. Okay, another one. One more. Well, it doesn't. That's not fair because you guys are automatically going to win. I love games and I'm pretty competitive, so this is not fair. Okay, what about Shapely Shubik? How many points? Since we haven't done one of those.
Let's do 100 since we haven't done one of those yet. Figure out-
100? You've done 100.
Oh, I meant just like of the Shubik, just to
yeah.
see what the questions look like.
Yeah. So solve. So Shapely Shubik power. We have a quota of 9. The weight is 653. Pause. Okay. So any answers? Okay. Yes, Pablo. Player 1 is 2/3. That's what I got. Player 2 and player 3 are 1/6 each. And we did percentages. So 2/3 is 67% about. Okay, good job, guys. Let me stop the recording. So that was just the review for the test on Wednesday.